Hello everyone, welcome back to the channel. Today we're diving into some of the most essential tools chemists use to understand what substances are made of. These concepts help us to figure out the simplest ratios of atoms in a compound. If you ever wondered how we know what a chemical formula like C6H12O6 really means, or how scientists determine what's in a mysterious white powder, this is where it all starts. Let's start with percent by mass. This tells us what portion of a compound's mass comes from a specific element. What is the percent by mass of carbon and carbon dioxide? So let's start with the molar mass. Okay, so for carbon, the molar mass is going to equal 12 grams per mole. For the oxygen, okay, that's going to be 2 times 16, because remember CO2 is carbon dioxide. So I have 12. I'm going to add 32 to this. That gives me a total mass of 44 grams per mole. So the percent by mass of carbon, I'll take the mass of carbon, which is 12, divided by the total mass, 44, times 100. And that will give me the percent. So the percent here will be 27.3% carbon. The next thing we will do is learn to write some empirical formulas. By definition, empirical formulas are the simplest whole number ratio of atoms in a compound. To achieve this, always assume 100 grams of the sample. So if I were to tell you that it's 40% carbon, that means I have 40 grams of carbon. Then convert your grams into moles. So I'll take my grams of sample, and divide it by the molecular mass or molar mass. Then we're going to set up a ratio between each of the different elements and reduce the ratio by dividing all by the smallest mole value. And if needed, we'll multiply to get all whole numbers. Our first sample problem says a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. What is the empirical formula? I like to list each element: carbon, hydrogen, and oxygen. If I assume 100 grams, that means I have 40 grams of carbon, 6.7 grams of hydrogen, and 53.3 grams of oxygen. All right, so let's convert to moles. So I'll divide carbon, its molar mass is 12 off the periodic table. Hydrogen is 1. Oxygen is 16. Okay, when I divide these, I get 3.33, 6.7, and 3.33. We'll divide each one by the smallest, which is 3.33. We're going to set these up into a ratio. So this is a 1 to 2 to 1 ratio. So my empirical formula is going to be CH2O. The last problem was straightforward. This one's going to be a bit more thought-provoking. I have phosphorus and oxygen. The problem says I have 56.3% phosphorus, so I'm going to assume 100 grams. The remaining portion of this will be oxygen, so that'll be 100 minus 56.3, so that's going to equal 43.7 grams of oxygen. Let's convert these into moles by dividing each one by its molar mass. So I'm dividing by 31 and 16. So I get 1.816 and 2.731. Okay, set that up in a ratio. I divide both by the smallest, 1.816. Okay, so this ratio will be a 1 to 1.5. All right, so we're going to multiply this times a number that will give us whole numbers. So we'll multiply all this times 2. So this gives me a 2 to 3 ratio. So my formula is going to be P2O3. That will be the empirical formula. The next order of progression will be molecular formulas. Molecular formulas tell us the actual number of atoms in a molecule, whereas empirical formulas, what's the simplest whole number ratio, molecular formulas give us the actual number of each type atom per molecule. All right, so here we have a hydrocarbon that contains carbon and hydrogen. It's 83.6 grams of carbon and 16.4 grams of hydrogen. Divide this one by 12, this one by 1. So we're going to do an empirical formula just like before. Okay, so I get a 7 to 16.4. Divide both by the smallest. So I get a 1 to 2.34. Okay, let's multiply this times 3 because I want whole numbers. And 0.34 is essentially a third. So I'll get a 3 to 7 ratio. So my empirical formula is going to be C3H7. All right, so we do that. Now let's continue on. And we have just a couple more steps. We can get the molecular formula. Let's find the empirical weight here. For carbon, I have 3 of those times 12. And for hydrogen, I have 7 of those times 1. So that gives me 36 plus 7, that gives me 43. The molar mass here is 86.2, so I'm going to say 86.2 divided by 43, and this gives me a multiplier. Okay, so this goes 2 times. So I'm going to say the C3H7 times 2. All right, so it gives me C6H14 for my molecular formula. All right, to test your knowledge, I'm including here a kind of a challenging problem, and let's see if you can try it on your own. Good luck, and I'll show you the answer in a few seconds. Hopefully you got this answer. C6H14 N2. If you did, congratulations. If you found this video helpful, give it a like and hit that subscribe button. Thank you for watching.